Now let's deal with parallel circuits. I don't get many questions on series circuits. The circuit that's probably of most interest probably is the parallel circuit. We will deal more with parallel circuits when we get on to where we're applying it to our systems and so on. Let's go through and list the parameters and how we deal with each of the parameters in a parallel circuit. Now I've got a parallel circuit drawn here fed by DC source of supply. In other words, I could identify these by resistor 1, resistor 2, and resistor 3, all fed by a voltage. Now, in a parallel circuit, our voltages now will all be the same. So I'll write same for our voltages. All our voltages on our resistors in parallel will be the same. The current now in a parallel circuit will be additive. The resistance values now for this circuit, we'll use what we call the reciprocal method, and I'll work this out with you. Well, it's a special method. Now, we said power in any circuit was additive. Now there again, remember we did the same thing for a series circuit. We listed each of the parameters and how we treat each of those parameters in each of those circuits. Now, you want to remember this and remember the difference between the series and the parallel when you apply it to your circuits. Now, this reciprocal method for resistors is probably the most tricky. There's more than the reciprocal method. I can show you some shortcuts, and we'll do that in just a little bit. Now, the reciprocal method of calculating resistors, if I had values of resistors up here that were, let's say we've got 5 ohms, let's say we've got 10 ohms, and let's put 30 ohms up here. Let's say that I have 3 resistors in parallel, and that I want to come up with a value of resistance for a total. In other words, I want to find out what their combined effect for resistance would be. In other words, I want to find total resistance. Now, the reciprocal method works for all of them. Regardless of how many and what their values are, you can use the reciprocal method. Now, remember that when we found the reciprocal of a number, we took that value into 1. Now, if I take the values of resistance, I've got 5, 10, and 30, and make reciprocals out of those, then I'm taking those values into 1. Now, the formula for the reciprocal method is like this. My total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, what we have to do here is find reciprocals, like I've done, add them together, and then take the reciprocal of it again, or divide that value into 1. Okay? Now, I've made reciprocals out of these. You'll remember that in the first year when you had fractions, that before I could add those fractions, they have to be the same common denominator. the common denominator, in other words, that number that would be divisible by all of those numbers would be 30. 5 into 30 goes 6 times 1, so we have 6 over 30. 10 into 30, 3 times 1, so we have 3 over 30. 30 into 30 goes once, times 1 is 1. Now if I add those values all together, I would have 10 over 30. Now what I want to do is make a reciprocal out of that number, which would mean I'm taking 1 and dividing 10/30ths into that. Remember now when we divide fractions that we invert the divisor and multiply? If I do that, I would have then 1 times, I'm going to invert this now, this is my divisor, I'm going to invert that. So I'll have 30 over 10, now I'll make this a fraction, multiply across the top and across the bottom, I would have 30 over 10, which is equal to 3. In other words, my combined resistance of those three together would give me a total resistance of 3 ohms. Now you'll know you have to have a value that's lower than the lowest resistor there. Resistors in parallel are inversely proportional, which means that if I have resistors in parallel, the more I put in parallel, the lower my resistance is going to be. That's an inverse relationship. So my resistance is lower than the lowest resistor I've got. Now this was a reciprocal method. This is the formula that we would use for the reciprocal method. Now there are times where we might not have to go to all that much trouble to calculate out the resistance. One in particular might be that if I had, say, 2 resistors, or let's leave that resistor in there. Let's say we've got our 3 resistors, but let's say all of them are 30 ohm. If they're all 30 ohm, all I have to do to calculate that out would be to take the value of resistance and divide it by the number of the resistors that I've got. So I would take my 30 and divide that by 3, and that would be equal to 10 ohm. So all 3 of those resistors together would give me a value of 10 ohm. Now the formula for that one would be R sub T is equal to the value of my resistance divided by the number of them that I've got. Okay. Now let's try something else again. Let's say that I've got 2 resistors this time. And let's say that I've got one that is 30 and the other one that is 20 ohms. Okay? Now, when we have 2 in parallel and they're unequal, we would use what we call the unequal branch method. And that formula would be like this. R sub T then is equal to R1 times R2 all over R1 plus R2. Which means then that I would multiply, I would take 20 times 30 and divide it by 20 plus 30. That would be equal to then what, 600 divided by 50, and that's going to go in there 12 times for 12 ohms resistance. If I would show the one resistor that would represent the both of those resistors, it would be a 12 ohm resistor. Okay, now we've got 3 formulas that we can use for finding resistance in parallel. And like I say, this is the reciprocal method. This is the equal branch. Method. In other words, anytime you hear it referred to branches, you know it's in parallel. And of course the voltage is the same across all its parts. The current is additive. The resistance, you use the reciprocal method, or any one of these three. Now we also then, this particular formula is what we call the unequal branch. Those are the three formulas. I'd remember those. Make your work a lot easier a lot of times if you know that if you take your resistance. Now you don't add up your resistors, you take your value of resistance when they're equal and divide it by the number of them that you've got, and you'll get your total resistance. There are times where you may have three resistors, and maybe, for example, say I have two 20s. What I could do is join those two by the equal branch, which will give me 10. Take that 10 with that 30 on the unequal branch method. Or, you can use maybe sometimes the unequal twice. Or if I had all three different resistors, I could use the unequal branch twice. I could join two, take that value with the next one, join those for my total resistance for that circuit. Now in your section 4, 2-4, second year now, assignment sheet number 1 of block 2, unit 9. Let's take that very first problem, solve it. It's under assignment sheet number 1, number 1, solve for the quantities indicated. Now I've got it drawn out. I've got the parameters that we're looking for. Now we have a parallel circuit here. The values of resistance are equal, and if you'll remember, we use an equal branch method to find total. In other words, if I want to find total resistance here, we aren't asked for that, but if I want to find total resistance, I would take my R sub T is equal to the value of my resistance, divide it by the number of them that I've got. I would be taking 10 divided by 2, which would be then 5 ohms resistance for my total. Okay? Now we're being asked for the voltage across resistor 1. That's pretty easy if you understand how we treat each of the parameters. We know in a parallel circuit that the voltage drops on those resistors are both the same. In other words, if I've got 50 volts for a total, I'm going to have a voltage of 50 across each one of those resistors for a parameter. So let's just put 50 over here. Now the current through resistor number 1, now this is our resistor number 1. If I know two parameters for a resistor, I can find the third and the fourth. If I know that that resistor has a 50 volt drop across it, in fact both of them we know are going to have a 50 volt drop across it, I can then, using Ohm's law for current, I can divide the voltage by the resistance. In that case I would have 50 then divided by 10, and I would have 5 amps then flowing through resistor number 1. We'll put 5 amps there. Okay. Now voltage across resistor number 2 is also going to be 50. We'll put that up there. The current then, because they're equal, current takes the path of least resistance. Current's going to divide evenly. If I have 10 ohms for both resistors, we know we're also going to have 5 amp there. My total now, if I put an ammeter in this circuit, I would have a total then of the two values in each. In other words, each branch has 5 amps. I total that up, I would have 10 amps for a total current in that circuit. Now, my total current will be up to the point that it first divides. In other words, I would have 10 amp from either way up to the point where it first divides. A lot of times a circuit, parallel circuit now, will be referred to as a current dividing circuit, where a series circuit would be referred to as a voltage dividing circuit. Now I've got another problem on the board, and this one comes from Block 2, Unit 9 on our parallel circuits. This comes from assignment sheet 4, number 3. I've got it drawn out here fairly close to what it is in your book. Then also we're going to look for these variables. I've taken this one because this was a particular challenge, and I would like to talk you through it so you can see what procedures we do. Also, this is a good application of power that we've just worked with. I have some values down here that are similar to the parallel circuit that we worked before. In other words, 5 ohms, 10 ohms, and 30 ohms. We know that if we take those values, use the reciprocal method, as we did before, then our total resistance in that circuit, if I would redraw that circuit, our total resistance, represented by one resistor here, would be 3 ohms. And we also know that from our given problem that the total power is 48 watts. Now we're looking for total resistance. We found that through the reciprocal method, so let's put that in there. We have 3 ohms resistance. Our total current now. And here's where we have to take what we know, come up with a formula, and then isolate the variable out of that formula that we need. Now, we know what total power is, we know what total resistance is, we want to find total current. If I write down all the variables that we know, we're dealing with total power, we're dealing with total current, and we're dealing with total resistance. Now, if I take a formula that has all 3 of those variables, if you'll remember, that's our power loss formula. P is equal to I squared R. Now, we know power, we know resistance, we're looking for current. Remember that to isolate that variable out of the right side of this equation, that I would have to divide both sides by R. I would have I squared then is equal to P over R. Square root both sides, I would have to take then I squared and the square root of P over R. In other words, I've gone an extra step so just so you can see what I've done. I want I instead of I squared, so I'd have to take square root of the left side. That means I have to also do it to the right side. Then I've got the formula then, I then is equal to the square root of P over R. Okay? Now, if I plug in what I know, I'm going to take the square root of, now I know my total power to be 48. I know that my resistance, my total resistance is 3. Okay, if I divide 3 into that, I'll have the square root, in other words, 3 into 48, now I'll have the square root of 16, which is equal to 4. So my total current then is going to be 4 amp. Okay, so we can put 4 amp in here. Now you see what we did, we took the variables that we had, parameters for the total in this case, came up with our formula, isolated the variable that we needed, plugged in what we know, you see, and solved for total current. And we found out we had 4 amps in that circuit. Now, if I know if I know also now, I know that I have total current. I have total power 48 watt. Total current is 4 amp. Total resistance is 3 ohm. Now, we're looking for total voltage. If I take total values, I'll get total values. We know that the voltage is equal to the current times the resistance. In this case, I have 4 then times 3 times 3, which the volt means the voltage then, my total voltage would be equal to 12 volt. So we'll have 12 volt. Okay. Now, we know that if I was to label this for voltage, we'd have 12 volt. Now this is a parallel circuit. I have right here then 12 volt. I would have, if I was to label that total resistance for voltage, I'd have 12 volt across there. That means we would have 12 volt across every one of those resistors, because we know that in a series circuit, or in a parallel circuit, we know that in a parallel circuit that the voltage drop, you see, the voltage drop is the same for all resistors. So that my total voltage and the voltage across each of those resistors is the same. Now, we want to find now the current through resistor number 1, which is this resistor right here. We have 30 ohms there, and we also have 12 volt. To find the current from Ohm's law, we take the voltage there and divide it by the resistance. Our voltage is 12. Our resistance is 30. Okay. We're going to take 12 now, divide 30 into that. You see, we're going to go in there, we're going to have 0.4. We're going to have 0.4 amps through this resistor right here. If I put an ammeter in here, I would have 0.4 amps. Now the current that I've got in there has to add up to be the total current of 4 amps. If I've got 0.4 here, then as I go back through that, the other two have to make up the balance of that 4. We don't have to solve it. Let's do it anyway though. Let's go back and prove this to be true. If I go back to this resistor now and find the value of current, remember again, I can take Ohm's law. Voltage divided by resistance, I would take 12 now, divide it by 10. See, I would have what, 12? I would have 1.2 amp current. I'd have 1.2 amp right here in this particular resistor. Remember, they have to all of those have to add up to be the total, which if I put in here, you see, would be 4 amp. Okay, now this resistor up here now, 12 again now, we take the current equal to the voltage divided by the resistance. I'm going to take 12 now and divide that by 5. And there now, you see, if I divide that in there, that's going to go in there, what? 2.4. 2.4. Okay? Amp. So I've got 2.4 amp right there. Now that means then if I would add the currents and all those, it should be 4. Let's see how we did. We've got 1.2 amp and 0.4 amp. Add those together, 4, 6, 10, carry, we'd have 4 amp then if I add those all together. So you see that all proved out.